Hello everyone, myself Marisharan. So this is my task 5 at need data for my data science internship. So today we'll be performing medical cost analysis and prediction. So here my data set is present along with my Jupyter notebook inside the Jupyter environment. So we'll be loading this data set into our notebook and we'll be performing analysis on it. So first we'll be pre-processing our data set, and after that we'll be visualizing, and finally we'll be developing a model to predict the cost column. So first I'm importing the pandas and numpy, and after that some packages for visualization, and this one to ignore all the warnings. So first I'm importing these necessary library functions. So after that I'll be loading my data set using the read underscore CSV function under pandas. So on that I'll be looking at the first 5 records. So I loaded, and this is what my first 5 records of the insurance.csv file looks like. So it has age column, sex column, BMI column, children, smoker, region, charges. So using this function, I can look at the data types of my data set. So you can see age column is categorized as integer. So only sex column and smoker column and region column are categorized as object variable. So we'll be performing pre-processing to convert them into integer or float data types for building our model and also for visualization. So first I'm using this isNull function and sum function to check if there are any null values present in our data set. So this is function is used to find if there are any null values present. So if there are no null values, it will result false, and the sum function is used to sum them up. So you can see there are no null values present in our data set. So next we can go with pre-processing, where I'll be converting these categorical columns into numerical values. So here only these 3 are in the form of object variable. So I'm using this label encoder function. So this is the method I'll be using to convert the object variable into numerical variable. So this is present under the package sklearn, and that under preprocess model it is present. So I'm importing that, and I'm loading my data set under the different name this time, which is df underscore aug. So our raw data set is present under the variable df. So first I'm loading my data set using the same function, and after that this LE variable has my label encoder function, and here is where I'm performing my label encoding to my 6 column. So what it does is that, so first we'll perform them and I'll explain. So this is what my new data set looks like. So you can see my 6 column is converted into zeros and ones. Same happened in smoker and region column. The smoker column has binary thing, which is yes or no, if the person is a smoker or not, and the region column has let's see how many types it has. So d dot, I'm using this, first I'm slicing the region column, and I'm using this value underscore counts functional. So there are only 4 categories present under the region column. So let's also look at the original ones, the raw ones, just ds region. Same thing I'm writing for the raw data set. So you can see the labeling. You can understand from this one that 0 stands for northeast, and 1 stands for northwest, and 3 represents southwest, 2 represents southeast. So this is how the label encoder works. So we'll be labeling all the categorical variables, and we'll be performing the pre-processing. So you can see 6 column has only 2 variables, which is female and male. So 0 for female, 1 for male, and also the smoker column, it has yes or no, if the person is a smoker or not. So 1 for yes and 0 for no. And the region column has 4 regions. So each label representing the respective regions. So that's how we have done our pre-processing. So we have converted all the non-categorical or the integer data types into categorical data types. So using our label encoder method. So after that, I am plotting the heat map. So here you can see we have plotted them. First, I'm using this core function, CORR function, to find the correlation between all the numerical and float columns. So as you know, we have reprocessed them. So all of them are in the form of numerical and float data type. So we'll be performing correlation between all the columns. So there are 7 columns. So I have performed the correlation between all of them, and we have plotted a heat map for them. So this CORR variable has the correlation matrix between all of them. So I'm using this heat map function, and inside that I'm passing this one, the matrix, and C map represents color map. So inside that I'm passing this one for the color. So for example, if there are no C maps, and this is the default color that our heat map takes. So if I want that, I can mention it using this one. And there are many other things like cold warm. There are other things, you can use that. And you can see this is our target variable. So this is our target column. So I'm slicing this column and then sorting them. So from this, what you can understand, so I'm using this, this is my correlation variable as the correlation matrix. And from that, I will slicing the charges column alone. So using this sort underscore values and sorting them. So this is what it looks like. So from this, we can understand the region column affects the least. My charges are affected least by the region column. And the smoker column affects is at the most. So this is what my observation is from this one. So moving on to the next plot, and plotting a distribution plot for the smokers and non-smokers for the charges column. So for smokers, this is the distribution plot, and for the non-smokers, this is the distribution plot for the charges column. So for that, I am using this function which specifies the index of my plot where it needs to be plotted. So for example, if I'm changing the index as, so now you can see like so now you can see the first one has smokers and the second one has non-smokers. Now their position are interchanged. The first one has non-smoker, the second one has smokers. So that's what this function is used for. So for plotting this one, I'm using the function called distplot under the sequence. So the first part will be my data set, and then first I'm slicing my data set, and first I'm selecting my data set, which is only for non-smoker, only for smokers. So I'm going to reverse. Only for smokers. So here you can see first 1 stands for smokers and 0 stands for non-smokers. We know that we know that 1 stands for smokers, 0 stands for non-smokers. So for example, if I'm changing this one, this is our raw data set. So the smoker means yes, smoker is this. The same thing is plotted. So from this you can understand the concept. So first I'm selecting my data set and I'm slicing only the charges column. So my x-axis will be the charges column. So for that I'm plotting the distribution graph. So this is what it looks like. And after that I'm plotting a bar chart for the smoker column alone. And I'm using this cat plot, which is basically categorical plot, using which we can plot a graph between numerical and categorical variable or between categorical variables. So here the smoker column is a categorical variable. For that I'm plotting a count plot, and I'm differentiating them based on these texts. So using this UE function, you can specify any categorical column inside it, and the output will be categorized or differentiated based on this one, and also based on the color. So here I'm mentioning that. So I'm using this cat plot, and my x-axis is smoker column, and it is a count. Based on the count, we'll be plotting them. So I'm mentioning the current as count, and the color difference as x, and our data set is the raw one. So the data equal to ds. So in that I'm plotting it, and after that I'm plotting the while plot for the sex column and charges column. So this is a categorical variable. So as I said earlier, using the cat plot, we can plot a graph between numerical and categorical variables. So our x-axis is a categorical variable and our y-axis is a numerical variable. And to differentiate that, I'm using the smoker categorical column, and the kind is violin, and our data set is the raw one. So we have plotted the wire graphs. So after that I'm plotting the box plot for women. So here I'm using this function title to title the chart, and that's basic. And I'm using this box plot function. Using box plot function, I can plot the box plot. So inside that, my y-axis is smoker, which is a categorical column, and my data set contains only for women. And in that, our y-axis is smoker and x column is charges, and we are drawing them in the horizontal way. So our orient is h, and this is our color. So without this is what you get. So I can mention the color for my, and so after that I'm doing the same for men. So one standard, one represents men. So I'm doing the same one, and this is what my output looks like. And here our palette is rainbow, and you can change the magma. I can copy this one and paste it here. So that's how it looks. Next time, plotting a distribution graph for an age column alone. So I'm using this plot function. So you can see, usually Cbus throws a warning for using this dist plot. It will say you can use this plot dis without the dplot. But you can look at this one. There is a line drawn here for the disk plot. But when I'm using this plot, you can see the whole thing changes. So basically, you don't have to look at the warnings and all and worry. You can go with whatever you can. So this one looks good. So for that, I'm using this function, this plot, and parameter my data set is age column, and the color is G. So for example, if I'm replacing it with B, you can see everything is changed, the color is changed. So after that, I'm plotting the scatter plot and also the regression line using the function LM plot under the Cbus. So what this LM plot does is that it will plot the scatter plot, and also it will draw the regression line for them. So that's what this LM plot does. So the x-axis is the age column and y-axis is our charges column, and we'll be differentiating them based on the smoker column. So for example, if this smoker column was in mode and we are writing for 6, you can see this is what we get. So and our data set is the pre-processed one, and this is the color. So if I'm not using the insert or and if I'm using the rainbow, and this is what the output looks like. So using the palette argument, you can change the color of our output. And now I'm plotting the distribution plot for the BMI column, and I'm using the same function, same concept. I'm passing the BMI column, I'm slicing it and passing it. I can either use this method, or I can use this method to slice a particular column. Then I'm doing the same for BMI is greater than or equal to 30, and for the charges column. and drawing a distribution plot. So from this you can see the distribution is somewhat left skewed, and doing the same for the and then doing the same for those with BMI less than 30, and this is their charges. So this is also somewhat left skewed. So after that, I'm plotting a scatter plot for my BMI column and charges column. So this is what my scatter plot looks like. And also I'm plotting a regression line. And for the same I'm plot using the LN plot, I'm doing the same. But this time I have the regression line also. For the this is what the raw scatter plot looks like. And using this LN function, I've drawn this one. It has scatter plot and regression line as well. And also again I'm using this cat plot, categorical plot under the function C, under the package sequence. I'm using this function and plotting a graph for the children column, and the kind is count, and this is the color. I can change it to so this is how it looks like, and our data set is C preprocessed one. So finally I'm drawing a using cat plot. I'm drawing this bar chart, and here my x-axis smoker and the kind is count. So we are categorizing them, and the number of smokers between male and female is given here, and a single change is made. Our data set has only people with kids, so if they have no kids, they are excluded. So even here you can see most of the smokers are male and most of the non-smokers are female. So we are done with the exploration part. So we have again some knowledge. So after that we'll be developing a model. So it predicts our charges column. So this is our data set. So we'll be developing a model which uses these information, the first 6 columns information, and using that we'll be predicting the 7th column, which is the charges column. So the basic idea is for this record, the age is 19, and that person is a female, and her BMI is 27.9, and she has no children, and she is a smoker, and she is in the region 3, and this is her charges. And for the next person, these are her information. This is his information, and his charges is this one. So using this information will be developing a model. So for that I'm using this linear regression model, and for splitting our data set I'm using this function, which is train underscore test underscore split function. So using this function we'll be converting our input into a quadratic polynomial. For that I'm importing this one, and this one is for finding the accuracy of our model. So I'm importing them. So this is what my data set looks like. And after that, first I'm dropping my charges column from my dependent variable. So x has everything except the charges column, and y has only the charges column. So after that I'm splitting them into test and train data set. So using this test train split, and I'm passing my x and y's, and the redundant state as 0. So you can see this is the order that we need to follow. First comes the x train and then the x test. After that the y train followed by the y test. So here you can see I'm using that, I'm doing that. And I'm using the linear regression, the default one, to build my model. And after that I'm training my model using the x train and y train. And we are making predictions for the x test, and using the score function we are finding the accuracy for our linear regression. So usually I'll be using the score function to find the accuracy for our numerical column. So when it comes to linear regression we'll be using this one only. So using that, and we are getting 79% accuracy. After that This time we are dropping both the columns, charges and region column as well. So we are avoiding this region. Since the correlation between the charges column and region column is least, we are dropping the region column and building our model. So first we are dropping the region column and also the charges column, and using this function I'm converting my dependent variables into quadratic functions. So after that I am splitting my dataset into train and test dataset into independent and dependent dataset 2, and after that I'm forming my building and training my model, and after that I'm making my predictions, and finally you can see the accuracy is improved from 79 to 88, which is a huge jump. So using this one, our accuracy has been improved. So this is what this task is about. We have made a complete analysis and we have predicted the charges column for a given data set. So that's all. Thank you for watching. Thank you.